For more than 30 years, the Mary Rose ruled the seas until her sinking in 1545. Almost 500 years later, she was raised from the seabed. It was another 2 decades until the University of Kent became involved in the ship's conservation. In 2004, Professor Alan Chadwick was asked by the Mary Rose Trust to lend his advice to solving what was called the sulfur problem.
What we learnt from the early experiments is that the sulfur oxidation, the dangerous compounds, were more at the surface than in the depth of the wood. We also learnt that the sulfur problem was worse the nearer the samples had been taken from a piece of metal in the wood, iron in particular. So where there'd been an iron nail in the wood, which now will have completely rusted away, there was a build-up of the sulfur problem.
For many of the Mary Rose's artefacts, it was a race against time to prevent them from degrading any further. Together, the Mary Rose Conservation Team and the University of Kent's researchers, led by Professor Chadwick, carried out experiments on samples from the ship using powerful X-ray producing machines called synchrotrons to reveal the extent of the damage caused by the seawater. Professor Eleanor Schofield joined Professor Chadwick's team in 2009, and here at the UK's National Synchrotron Facility, she's helped develop a programme of experiments where the status of the ship and its many artefacts can be monitored in real time.
Some of the issues we saw with the artefacts, particularly with the wooden artefacts, is that you would see salts develop on them. This is when they were exposed to air and humidity, and sometimes with elevated temperature too. And these salts would form, and they don't look very good, but they also can be very damaging to the artefacts. So what we wanted to do using diamond was to understand how they were formed and how they would develop over time, and then to develop treatments to try and solve that problem. When I first started working at the Mary Rose, we were particularly focused on preparing the ship for drying. It had been through a conservation treatment, and then we had to expose it to air to dry it. In doing that, we knew that we could cause some transformations of all the elements that were in the wood. So we set up a program of work with Diamond Light Source to take samples from the ship, bring them here, analyse them to understand what was happening.
Electrons are sent round a ring at effectively the speed of light. These electrons produce light, which can then be directed down passages known as beamlines, and in turn used on experiments like those on the Mary Rose. The whole system can be compared to a ring road with dozens of slip roads coming off it. It is down one of these slip roads, beamline B18, where the Mary Rose experiments have taken place.
In the case of the wood that we studied, Mary Rose had a couple of important components that are critical for determining the degradation processes. One is the sulfur and the other one is the iron. And the combination of the two is leading to, in a very long term, thanks to the exposure to oxygen, to the degradation processes. On B18 we can select the wavelength of the X-rays to correspond to the excitation of sulfur only or to the excitation of iron only. So we can study the chemistry of sulfur and the chemistry of the iron. The chemistry means, in our case, understanding what is the oxidation state, so how many electrons have been pulled out of the sulfur or the iron, and also the geometry of atoms that surround each of the absorbers that we have chosen.
I think some of the benefits of having a synchrotron, it enables you to penetrate in really small detail and look at the actual chemistry of individual elements, which you can't do with a range of other techniques, and that has enabled the conservation tactics used on the Mary Rose to developing both new methods and verifying methods in terms of what works, what doesn't work, what's most cost efficient, which is always a factor when treating large objects. So it's been very effective in helping preserve the ship.
If you think about it, the whole collection has essentially been marinating in seawater for nearly 500 years. So there's loads of stuff in it that you wouldn't find in normal kind of terrestrial or your everyday objects. So wood normally wouldn't contain these things, but you find all these elements from the seawater lodged in there in different forms. And what this facility allows us to do is to look how they change over time and then develop treatments to protect them for the future.
Thanks to the discoveries made during these experiments, the University of Kent researchers and the Mary Rose team were able to develop a special compound to treat the ship's timbers and artefacts.
We developed a method of making small nanoparticles of strontium carbonate, which we could soak into the artefact. These nanoparticles would react with any acid and essentially neutralize it. And they would sit there as a reservoir. The nanoparticles would be a reservoir that could mop up any sulfuric acid that formed over time.
Really what we were doing here was wanting to prove the chemistry, because this isn't really an ideal way in which we would apply it to the ship. So once we'd proved the concept worked, we then started looking at different application methods, and that's really some of the work that we're doing now, finding ways that we can incorporate the nanoparticles into different ways to get them into the wood.
The results are on display at the ship's dedicated museum. First opened in 2013 and then again after a major revamp in 2016, the Mary Rose Museum welcomes up to 250,000 tourists a year. Many point to the quality of the conservation work in enhancing the visitor experience.
It's really a fascinating collection because it really gives you that personal insight into day-to-day life in Tudor times. It wasn't just a warship, but it was where the crew members lived and worked day to day. So alongside weaponry, you also have very personal items, things like knit combs, shoes, clothing. So it really gives you an insight into Tudor life. Without all the conservation work, these artefacts wouldn't be here and they wouldn't be on display. And it's something that people find absolutely fascinating, that these artefacts are real. They were under the water for all of that time. They've then been raised and you know, through the conservation work, been preserved and put on display for people to enjoy and to view.
Preserving and presenting the thousands of artefacts in such a pristine condition has been central to the museum's popularity.
I think people have in their mind what the old museum used to be like, what the old ship hall was, and when they get here they're just absolutely blown away. If you have a look at our TripAdvisor reviews, you notice a lot of the comments that people are just absolutely blown away by what the museum looks like and the views of the ships and the artefacts now. And I think that really spreads. You know, people tell their friends and family, you must go see the Mary Rose. It looks absolutely incredible.
There's a growing focus at the museum on highlighting the various processes involved in the conservation, with a view to include more of this information in outreach projects.
If you have a look at our family groups in particular when they come to visit, really there's something to interest all ages, and what's really fascinating is how interested the children are. You'd say, well, how come the Mary Rose is here? How did it get here? It was underwater and then it was raised. And just watching them as they go around the museum and learning about the conservation process and all what went behind.
Specifically important to me is that people understand the amount of science, technology and engineering which are absolutely crucial for this collection. And that's not just now, it's been all the way through. It goes back to them finding the ship, excavating the ship, developing conservation treatments, developing this museum we're stood in now, developing the system that's drying the ship. It's just been absolutely crucial, and it always will be. And it's nice to get that message across to people and to give some people an idea of the range of jobs that you can have from STEM subjects.
Going forward, Professor Schofield, along with the team at the Mary Rose and their partners at the University of Kent and Diamond Light Source, will continue to develop a range of techniques for treating the artefacts, including the ship's bricks.
The issues that we see with the salts in the wood, we are starting to see in other materials. One of those is the bricks. So we have bricks in our galley and also used for some ballast. And what we've seen now is that you are getting these crystals forming on them. So we've traced those back to being a similar source to what's happening in the wood. And so now we're doing some work with the University of Kent to really understand what they are. Again, once we understand what they are, we can start to create ways to mitigate against them causing any damage.
The journey of preserving the Mary Rose in recent decades has been underpinned by pioneering science and technology. For the first time, the degradation and treatment of materials in the artefacts has been monitored in real time. This research contributed to the discovery of a special compound to treat the pride of the Tudor fleet, which in turn has enhanced the experience of visitors wanting to get a taste of life on the high seas nearly half a millennium ago.
Everything that we do in the conservation department and all of the research that we do is to make sure that that collection remains stable for as long as possible so that people can come to the museum and immerse themselves in Tudor life.
The problem posed by the complexity and the nature of the material itself that has helped us also to provide new techniques to be able to push a bit, our technology.
The museum is designed obviously to be interesting to all ages, and what we really hope is that we inspire those children as they grow up to keep returning, and obviously as they grow up bring their friends and their family back. It's not just here for us today, it's here for everybody in the future.